Potential energy, stored energy, energy waiting to happen, like gasoline in the car, loaded with potential energy. That is a chemical potential energy. So there's different types of potential energy, there's different types of kinetic energy, but energy is divided into two main types, and these are the types. So potential energy, storage, energy waiting to happen. Kinetic energy, energy of motion. Cannot escape. So the periodic table, if we're looking at metals, so most of the table is metals. And if we go toward the left, we're getting more metallic. If we go this way, we're getting more electronegative. Remember, the non-metals are over here, metalloids here. Most of the periodic table is metals. But what is a metal? A metal is a conductor. It acts as a conductor. It allows electrons to flow. It conducts electricity. So a conductor allows electrons to flow. And if you think of metals, the more metallic elements are freely giving up their electrons. Remember, the metal heads over here, Metallica's fan club, this group, they're going to give up their electrons. They're like, woo, heavy metal heads over here. They're going to give up their electrons. They let them go. They're free. Let them go. So they remember Leo goes rawr. So Leo, remember the lion? L-E-O, lose electrons, oxidized. So they become oxidized. Metals will become oxidized. Non-metals over this side, they want to hold on to their electrons. They're highly electronegative. They want to suck up all the electrons they can. So they go grrr. Remember, Leo goes grrr, G-E-R. G-E-R, gain electrons, become reduced. That's what they call it, reduced. So these are the nonmetals that will become reduced. They want to suck up the electrons. So a redox reaction is a reduction-oxidation reaction. That means it's a reaction in which one compound is going to be reduced and another compound is going to be oxidized. So if we think of it, the metals over here, the heavy metal heads, the Metallica fan club over here, they're going to lose their electrons. They lose them. They're free-spirited. Let them go. They lose them. They become oxidized. But they also, when they become oxidized, remember they lose their electrons, they're also called reducing agents because they cause the nonmetals to become reduced. Remember, they give their electrons to the nonmetals, and then the nonmetals become reduced. Elements that are oxidized are also called reducing agents because they give their electrons to nonmetals. The nonmetals, on the other hand, remember, gain electrons. So they become reduced. And if they become reduced, they act as oxidizing agents. So in other words, they take the electrons from the metal heads over here. So if the elements become reduced, they are oxidizing agents. If they become oxidized, they are reducing agents. Okay? So the reaction in which we have electrons gained and lost, we call a reduction-oxidation reaction, or the shorthand version is called a redox reaction. And that is what happens inside batteries. The circuit is just a pathway that electrons can travel. So here is a drawing of a circuit. This is the pathway that the electrons are going to travel. So remember, this is the battery. This is where the electrons, the chart, this is everything that's being stored in here. The electrical potential energy is stored in here. If we connect these, if this thing is closed, if the circuit is closed, you're really creating a highway for the electrons to travel. All right, so this end of the battery is the negative end. This end of the battery is the positive end. So we call it the positive terminal, negative terminal. But once you put the batteries in, you're completing the circuit. So now the circuit's complete. And if you have a light bulb or something over here, it can actually light the bulb. As the electrons go through, we're going to go through the light bulb, and that energy converted to light energy.